Alrighty, welcome back to my Slither.io Python slash Pygame tutorial series. And this time, the last video, all we went over was getting this window to render while getting the foundation of our game going, particularly with our main game class, which will be handling most of the logic along with our game loop which we created here. And so for this part, all I want to do is I want to get at least a part of a snake rendered and responsive to input. And this is how I've decided I was going to proceed with this. And some of you might not like this, but I feel like the simplest way to proceed with making a Slither.io game would be to make the snakes like different circles here, different orbs, and the more orbs you eat, or the more score you have, instead of the bigger your snake gets, it will just be he will have more of these. And of course, these will also get bigger as well. But it's not going to be one smooth snake like the original Slither.io game. Now, some of you may not like this. Now, for me, I would prefer this to completely copying a game that's already in existence. But this is also going to be a lot simpler, too, for when we want the snake to be longer, and it's much easier to just add on more circles to the end of a snake, and we would assign one with, I would say this one would be the head, and whenever this one moves, the other ones will later on repeat that movement so that all the other orbs follow the head orb here. This is how I'm going to do it. And now it kind of looks like a snowman here, but for me, this is the way I prefer to do it. So all I did here is I just created a circle image here using GIMP. You can do it with whatever you wish, as long as you can get some transparency in the corners. You don't want an ugly white background in the picture. Once you get your picture, you can actually just drag and drop and put it on the name of your project right here. So for me, I had it on desktop. I just dragged it over the name, and it added the picture right here. Alright, so what I'm going to do here is I'm going to create the player class, which again, I closed up my paint example. The player is just going to be one of these balls for now. He's not going to have any more length to him, but that'll be good for us to start. So I'm going to go to new Python file, and I'm going to call it player.py, and this will be my player class. So I'm going to type class player, and I'm going to create a constructor for this player. Init self. Now what the player is going to need is it's going to need first a Pygame rectangle object. So Pygame has a class called rect, which is just a rectangle which has an x, y, width, and height, and we're going to create one of those. So I'm going to import Pygame, and down here type self dot rect. Now rect is what I'm going to call it. You could call this hitbox or something else. This is what I'm calling it. I'm going to call it rect, and I'm going to set it equals to Pygame dot rect with a capital R, and inside of here you need 4 parameters: your x, your y, your width, and your height. Now I could put in some numbers here, but I do not want to hard code it. I'm going to put it in the constructor instead as parameters here. Oh, and I got the terms mixed up. Technically, these are arguments and these are parameters, but that's not very important. I'm going to put x, y, width, height. So we're still going to pass in these parameters here, but we're not going to choose random numbers to put here. We're just going to delay this work, put it inside of the main game file. I'll show that in a second. Another variable we're going to need is a Pygame texture. And for that, I'm actually going to create a temporary variable first. Image is equal to Pygame dot image.load. The pygame.image.load function will load an image with a certain file path, and if you dragged your image directly on the project path it should now appear with all your code, and since it's in the same directory, you can just put the file name in quotes. Body underscore red, which is what I chose to call it, .png. Now, the reason why I did not choose to make this self.image is because I actually want to resize it to whatever the user asked for width and height. So down here, I'll type self.texture. Now, this is our final texture variable. This is a temporary one. Now, the final texture variable is pygame.transform.scale. And before I continue, all I'm doing is I am resizing this temporary image variable so that it will match these parameters here. Self.texture equals pygame.transform.scale, and to scale, you need to specify what you're scaling. So here I'm going to put that temporary image variable, and then as a tuple, you put the dimensions that you want to scale it to. So I'm going to put width and height as a tuple. And so now this texture is going to be the stored texture for this player class here. Now, some of you that know Pygame pretty well might have this question: why are we using a rectangle and a texture when you can render with either one? You can draw a rectangle by itself on Pygame, and you can draw a texture by itself, but why am I using both? The reason I'm using both is because I want to render with the texture. So I don't want to just render a rectangle. I actually want to render this circle here. I want to render with the texture, but I want to use the position data of the rectangle. Now, why can't I just have a self.x and then a self.y and just store my own position variables? I am doing it this way because the pygame.rect class has a function called collideRect, which we'll use later. And if I don't use a rectangle object here, I'm not going to be able to take advantage of this collision function, which means that when we get down to making the snakes collide with each other and some dying, I'm going to have to write my own collision function, which can be pretty hairy. So I'm using texture to render, and I'm using the rectangle for its built-in collision methods. And if that doesn't really make sense, it will make more sense in the future. So right now we're good under player. I'm going to create a player inside the main game. Import, it's actually from player, import player. And I'm going to do this inside of main game's constructor. And I'm not doing this in main. I'm not going to put the player in here. Main game's controlling all of this game, so it's going to also control the player. Self.player is equal to player, and to create a player, we asked for 4 different parameters here, so I'm going to pass in 4 arguments. The starting x and y are going to be 0 and 0, so I just want the player to be at the origin. Now the starting width and the starting height are going to be, I think I'm just going to set them to the same as the texture. Now, I am hard coding this for now just because I could define a constant. And in fact, I'll do that. I don't want arbitrary numbers here. I want people to know what these numbers mean. I'm just going to make some constants up here. Starting width is equal to 50. Starting height is equal to 50. So every single time a new snake spawns or the player spawns, these are the dimensions they're going to keep by default, 50 and 50. So I'm going to put those constants in this place. This just makes your code a bit more self-documenting or just easier to read. So now that I have a player, the next thing I want to do is I'm actually going to give the player the exact same functions here, an update and a render, because On the outside, the whole game is updating, so every single object in the game is changing its position or updating its state or whatever, and it's rendering onto the screen. That's the game as a whole, but individually, every individual snake needs to update, and every individual snake needs to render. So this update function and this render function here, these are as a whole for the whole game. But the player is also going to need his own update and render function for the individual side. So I'm going to create an update function for the player. And right now, I'm actually going to skip this because I just want to draw the player on the screen. Next, I'm going to create the render function. And I like to say draw instead of render. Now, this is entirely preference. You can call this render, but I like render to mean the whole entirety of the game, and draw to be an individual item, which I would consider the player to be an individual part of it. You can call this render, that's entirely your preference. Inside of the draw function, like I mentioned earlier, we're going to be using texture to render this player. And to render a texture in Pygame, you would say your window.blit, and then inside of blit, you put in the texture self.texture, which is the variable we have here. Again, not image. Image is the raw texture by itself. Texture is what I resized the image to, just to make sure that its width and height are the exact same for the rectangle. And I might not have explained this very well, but like I mentioned, rectangle will be for collision, this will be for rendering, and if the rectangle has different dimensions than the image, we won't see it because it won't render, but that will mean that its hitbox will be too big or too small. So that's why they need to be the same. Back to drawing, window.blit self.texture, and then the next argument for window.blit would be, it would actually be, oh, I lost my train of thought. It's actually going to be a tuple, which defines the position for the texture. Self.rect.x. Again, this is what I'm using for all my position data and collision. Self.rect.x, self.rect.y. Yes, this does need to be in parentheses because it needs to be as a tuple. Now, this would draw the player on our screen, except window is undefined because window is actually a variable in main game here. Player does not own this variable. It wouldn't make sense if it did. But what that means is in order to actually make this defined, I have to pass it in as an argument, window. And so now we have a player with his starting methods here, starting variables, his update function, which we'll add to later, and then the drawing function here. And so now we can use the drawing function. I'm going to go back to main game.py, and inside of render, again, update is updating the game as a whole, render, rendering the game as a whole. And I left a gap right here from the last tutorial because I knew we would put something in between these two lines, in between clearing the screen and updating the display. This is where we're going to draw the player. I'm going to say, or type, I keep saying I'm going to say. I am saying it, but I'm also typing it. And I don't know if I've made that joke already. Self.player.draw. And since draw requires an argument, or it requires a window, I'll put the window in. And I almost did it again. But remember, when you're referencing a variable that belongs to a class inside its own class, you have to say self dot. So this is not correct. I have to say self dot window. I am referencing the main game's variable inside of main game. So I need self dot window. And this here should render the player in the corner of the screen, and it does here. The reason it rendered in the corner is because, and I'm explaining a lot of Pygame stuff. Again, if none of this is familiar, you should go to the resources from the first video in the description. But Pygame, its coordinate system is X gets bigger as it goes to the right, but Y actually gets bigger as your visual position goes downward. So it's kind of flipped from your Cartesian plane. So X is getting bigger as you go to the right, and Y gets bigger as you move down. And also the corner right here in Pygame, this corner right here is considered to be the position of what you're drawing, not the middle. Now the middle would be nice, and we're actually going to fix that later to kind of make it the middle. But for Pygame's purpose, this top left corner is the position. So when we tell, back to the code, when we tell the player to render at 0, 0, that will make its top left corner, which is where the position is saved, go to 0, 0 on the screen, which is the corner here, because Y is flipped. Y of 0 is not going to be down here, it's up here. But I think that's enough of that. The player is rendered on the screen, so now I just want to make him responsive to some input. And so this is where we're going to actually put some stuff inside of update. To make the player responsive to input, I need to first get the dictionary that stores all of the key states. Keys is equal to pygame.key.getPressed. And what this function does is it returns Pygame's dictionary, which stores all the different key types as well as a Boolean value for whether or not they are pressed. So I'm going to process that. If keys pygame.ka is equal to true, and since I'm doing equals true, I can actually just skip that. Then what I'm going to do here is I want the player to move to the left, which will be subtracting from the X. So I would type here self.rect.x minus equals, and I'll say 10 or something. Now again, here's another magic number. I don't want magic numbers. I want it to be clear what all these numbers are for, and I don't like hard coding, so I'm actually going to go back to the top, and I'm going to create a speed variable. Self.speed is equal to 10. And so I'm going to replace this with speed. And now I'm going to add the other keys. Oops. And then I'll do write pygame.kd self.rect.x plus equals speed. And I'm going to make the speed in the X and Y directions the exact same, since that would make the most sense for Slither.io. So I'm going to use the same variable for speed for going up and down. Pygame.kw, and remember in Pygame, the Y is basically flipped from your normal Cartesian plane. Going down makes the Y bigger, not going up. So self.rect.y, and if I want to go up, I have to subtract from this variable speed because it's flipped. And then finally keys pygame.ks self.rect.y plus equals speed. Now this, if I run it, it's not going to work because we haven't called this update function. What I mean by that is back in the main game class, we added the player's individual rendering, but we never added the player's individual updating. So here's the game's updating. Now here's the player's. Self.player.update. And this should now allow me to move the player when I press a button, and it didn't let me figure out what that was. I have done it again. I have fallen for one of the classic blunders. I forgot to put self.speed here in front of the speed variable, and I'll just specify this again because I am inside the player class and I am referencing a class's own variable inside the class itself. Moving on, if we run the program now, The player does in fact move, but he moves incredibly quickly. So what I could do is change the speed variable, but I actually don't want to do that. The reason why he's running super fast is not necessarily because the speed variable is too high, but because right now I'm not even monitoring the FPS of this game. So since what this program will do is it will try to run our script as quickly as possible, and since this is really easy for our computer to render or to load, this is probably running at well over 60 frames per second. And so what we want to do is stop it at 60, which will keep the player from moving quite so fast because update is being called as many times as possible. So what I'm going to do, and to do that, you need to create a variable for the clock. So Pygame has a built-in clock variable. So I'm going to create that inside the main game. Self.clock is equal to pygame.time.clock. So I stored the Pygame's clock, or I stored a clock variable from Pygame's time.clock method. And what I'm going to do down here in update is I'm going to say self.clock.tick. And what this function will do is it will control the FPS and it will keep your program from running above the given FPS. And I really like this function because FPS tracking in other programming libraries and languages is normally a bit harder than this. But here, all you need to do is say clock.tick, and here put in your frame rate. But a magic number, I don't want a magic number. I'm going to create a constant at the top. FPS is equal to 60. And so I'm going to replace this with FPS, even though I guarantee I am not going to be changing that variable to anything else throughout the remainder of the series. But now if I run it, the dot moves much more controllably. So I don't even need to change the speed variable. Hey, thank you very much for watching. This tutorial is getting pretty long, so in editing, I've decided to cut it here, and I'll see you in the next one.